Question 10 reads, the graph of h of x, which is equals to ax cubed plus bx squared, is drawn. The graph has turning points at the origin and at B, which has 4 and 32 as its coordinates. A is the x-intercept of h. 10.1. Show that A is equal to -1 and B is equal to 6. So, in order to solve for A and B on h of x, which we have a x cubed plus b x squared, we have to formulate two equations, and within these two equations we need to then solve for a and b simultaneously. So this is our original equation. What I can do is I can find the first derivative of this. That would be 3ax squared plus 2bx. Then these two, I will use information that has been given to me on this graph and within this little passage to try and find values to substitute. If I work with my first equation, the original one that describes the curve, I will have y is equals to ax cubed plus bx squared, and I have a coordinate that I can sub into there, which is b. So doing that, I'm going to have 32 is equal to a, x is 4 plus b, x is 4 squared, like that. Then we can 4 cubed, that will be 64a plus 16b from 4 squared times b. Then I will leave this here and go to this one and see what I can tell from the first derivative. Now remember, the first derivative describes the gradient, and we know that at the turning points the gradient is 0, which means here the gradient is 0 when x is 4, which means my gradient h prime of x is equals to 0, and this is equal to 3a x squared plus 2bx, and it's 0 when x is equal to 4, so I can substitute into x 4. And then I can simplify this equation. It will give me 48a plus 8b, which will be equal to 0, like that. And then now I have two equations that I can use. This is equation 2, then we can name this equation 1. And then it is up to you on which formula you would like to use in order to solve for this problem. The simplest one that I can see, since 16b is a multiple of 8b, what I'll do is I'll write 32 is equals to 64a plus 16b, and then I'm going to rewrite this equation underneath it. So I'm going to have 0 is equals to 48a plus 8b. And then what I'm going to do is I'm going to multiply this second equation, or this first equation actually, by 2. So everything is going to double. 48 times 2 is 96. So 0 times 2 is just 0. That stays the same. This changes to 96, and that is going to become 16. Then what I can do is subtract these two equations. So 32 minus 0, that's just 32. 64 minus 96, that gives me minus 32. And then 16b minus 16b, that is 0. So you can put plus 0 if you want to. Then we can divide by minus 32 on both sides, like that. and a will then be equal to -1. As we can see, we've shown a is equals to -1. Now we need to show that b is equal to 6. So since we have the value of a, I'll just use this equation to solve for b. So substituting the value of a, which is -1 here, plus 8b is equals to 0. This will be 8b, and -48, take it to the other side, it's going to be +48. Divide both sides by 8, and we know that 48 divided by 8 would give us +6. And there you have shown that b is equals to 6 and a is equals to -1. And remember, at this point, having these two equations, you are able to solve this problem a couple of different ways. I use the process of elimination. You can use the process of substitution. That would mean make b or a subject to the formula, then substitute into the other equation. But whenever you find it that one variable is a multiple of another in the different equation, then you can just use the process of elimination, as that would be quicker.